All right, let's go through section B now. So first of all, just some properties about the graphs of these quadratics. So we sometimes call them parabolas. So first of all, there's a couple of key things. So the first key thing is to identify basically the vertex. So a vertex is basically the highest or the lowest point. So we're looking down here. This one parabola reaches, maybe I should have used a more contrasting color there. Let's change it to red. That you can see more clearly. That's sort of the highest point that it reaches. It's also the maximum of the parabola in this case, but that's what the vertex is that particular point. On the right one, you can see it reaches this lowest point, so the minimum at the very bottom there, and that's the vertex as well. All right, the axis of symmetry, that's basically a vertical line that you can imagine that splits the parabola in half, and those two halves are basically identical. If you were to reflect the parabola over that axis, you'd get the other half of the parabola. And that's what we mean by congruent. They're same shape, just oriented differently. So in this case, the actual axis of symmetry, it always goes through the vertex. So the vertex is not only your lowest or your highest point, but it's the point in which the parabola is also symmetric around. So let's go through. So again, we've drawn it on here. So the vertex in the left one, so let's say this is A and this is B. Vertex in the left one is -3, -4. Just make that a negative. Just be careful not to accidentally confuse. Let's just erase that, make that a little neater, right? Don't confuse your X and Y values. So then the equation of the axis of symmetry, since it's a vertical line, you can actually write this as x equals -3. The domain, so the domain, I mean, if you go left or right, you can take on any value of x. So the domain will just be x, such that x can be anything, so any real number. How about the range? So the range is going to be slightly different, so it's going to be y, but you can see that you have that maximum point at -4, and you can take on any y value below or equal to -4. So that's what we're going to say here, is y is going to be equal to less than or equal to -4. And it's going to be any real number below that point. All right, so that's for part A. For part B, the vertex, just follow along with your vertex there, and you can see it's 5, 1. The axis of symmetry is that vertical line, so it's going to be x equal to 5. And again, you can take on any x value. You can go off left or right as far as you can. And again, there is going to be some sort of further work for the domain, and or for the range, I should say. And that's because if you look at the graph, your minimum point is 1, and you're going to go upwards from there. So y is going to be anything greater than or equal to 1. It's also a real number as well too, because you can take on any value that's bigger than 1. All right, for this next example, what you have is you have a bunch of functions that are given, and they're given generally in vertex form. And we're going to find these important pieces of information. So for the first one, even though it might not look like it because you don't have an x minus or an x plus something squared, it is in vertex form. Whoa, what's going on there? It's just that your x value of the vertex is 0, so it'd be like x minus 0, so that's why it just looks like x squared. The other value is 4. In this case, because your vertex is at 0, 4, that means your axis of symmetry is not going to be x equals 4. That is just plain wrong. It's going to be x equals 0. And the direction of opening, so we just look, is the start of this positive or negative? So we have nothing indicating it's negative, so it's positive. So it's going to be upwards. Or you could just say up. All right, let's continue onwards here. So to find the vertex, look at your value within the brackets and outside the brackets, and then just be careful. So for the x value, you always have to flip the sign. So it looks like +7 there. So that means the vertex is at -7. So just like with transformations when we were dealing with horizontal shifts, it was always the opposite direction, and that's because this is a transformation. The y, though, stays the same. So it's -3 on the outside, so -3 there. So your axis of symmetry then is just equal to the x value in your vertex, so -7. To find out the direction of opening, go over to your function over here. You have a negative sign out in front, and that's going to mean you open down or downwards. All right, so again, let's go over this next one. So you have an x minus 4 squared and a +1. So remember to flip the sign of your x value, but maintain the sign of your y value. So 4, 1 is your vertex. So that means your axis of symmetry is equal to 4. And the opening, what do we have in front? So 3 is a positive number, so it's going to open upwards. All right, let's look at this last one. So this last one is a bit cruel. It's not in vertex form, so you can't just instantly write out the answer here. But what you can do is, because it's in factored form, we can figure out the roots real quick. So let's do that. So the roots are just going to be these two numbers, but with their signs flipped. So x equal to -2 and x equal to 5 are the two roots. So just remember to flip the signs. So that means the x value of the vertex it's just going to actually be at exactly the midway point between those two roots. So you could find the average of those two roots. So like -2 plus 5 divided by 2. You don't have to write this out if you can just see it and see that it should be, let's say 3/2. That's fine. So that's the x value of our vertex. So you could already write that down, 3/2. And then the next part that you could do is, what's the y value at that point? So to find the y value, you just simply substitute it in. So f of 3/2. So -3, 3/2 plus 2, times 3/2 minus 5, which is just equal to, if you calculate that out, what you should get is 36.75. So we can just write that down there. So your axis of symmetry again is your x value, so 3/2. What direction are we going? So if we look at the sign in front of our function, we have a negative sign, so it's going to go downwards. All right, so that's section 2, just going over the graph and some key features like the vertex and axis of symmetry.